This video will give you a deeper dive into Cloud Foundry runtimes and the architecture of Cloud Foundry on Bluemix. In this video, you will learn about runtimes and buildpacks. You will understand how a particular buildpack is selected for an application and how to override the defaults on Bluemix. Then, you will learn about Bluemix PaaS Cloud Foundry architecture components and the process used when your application is staged and deployed to Bluemix. A buildpack is a collection of scripts that prepare your code for execution on the target platform as a service environment. A buildpack gathers the runtime and the framework dependencies of an application. Then, it packages them with the application into a droplet that could be deployed to the cloud. The diagram depicts the deployment of an application to a container running with the Cloud Foundry architecture. Bluemix is currently running the Diego version of Cloud Foundry. Buildpacks are automatically selected when the application is staged for deployment. The buildpack model addresses the complexity of runtime composition for modern applications. By collecting and configuring the runtime executable as logical units, the buildpack simplifies the process for deploying cloud applications. Bluemix includes a large number of runtimes for your Cloud Foundry applications. By default, when an application is staged, the buildpack is automatically selected based upon the artifacts for the application. For Liberty, this could be just a war or ear file or a server XML file. For Node.js, the presence of a package.json file is used. A requirements file for Python, and so on with the various runtimes. The buildpacks are matched by position order, with the lowest number buildpack being used for the runtime of the application. If you want to override and specifically choose a buildpack, you can use the -b option to the application push from the CLI, using either the name shown for the buildpack or a URL to a Git repository with the buildpack to use. For example, to override the IBM default Node.js buildpack called SDK for Node.js, you would specify -b Node.js_buildpack during staging the application. Buildpacks cache dependencies. Typically, a current level and 2 prior levels are available. If an application requests a runtime version that is not available in the buildpack, the deployment will fail. Buildpacks also have default runtimes, and if a runtime default changes, this may affect your application. So it is a best practice to specify the desired runtime version along with the other application dependencies. This diagram shows the Cloud Foundry architecture and components from an operations perspective. The router routes incoming traffic to the appropriate component, usually the cloud controller or a running application on a cell. The authentication layer is implemented through an OAuth server. The login server also works with that to provide identity management services. The cloud controller is responsible for managing the lifecycle of applications. When a developer pushes an application to Cloud Foundry, the cloud controller stores the raw application bits, creates a record to track the application metadata, and creates a staging task for a cell to execute, and then a long-range task for running one or more instances of the application. The cloud controller also maintains records of organizations, spaces, services, service instances, user roles, and more. Application availability is coordinated by the in-sync, BBS, and cell reps components. The in-sync component stores the desired number of instances or long-range processes in the BBS, and the BBS monitors the report of actual instances from the cell reps. Applications are executed down at the cell. The cell manages application instances, tracks started instances, and broadcasts state messages. Application instances live inside Garden containers. Garden manages isolated, ephemeral, and resource-controlled environments. Containerization ensures that application instances run in isolation and get their fair share of resources and are protected from noisy neighbors. The blob store holds application artifacts, buildpacks, and droplets. Applications typically depend on services such as databases or third-party providers. When a developer provisions and binds a service to an application, the service broker for that service is responsible for providing the service instance. Down in the message bus layer, the key components for communicating in the Cloud Foundry Diego system is the Bulletin Board Service, or BBS. Cloud Foundry uses HTTPS to communicate between components and stores frequently updated information in the Diego Bulletin Board Service and long-lived data in console. The NAT's message bus is used by the router emitter to broadcast routing tables to the router. For logging and statistics, the metrics collector gathers metrics from all the components. Operators can use this information to monitor an instance of Cloud Foundry. The application log aggregator streams application logs and other events to the developer. This diagram shows the detail of the staging and deployment process when using a build pack. The sequence of events is as follows. At the command line, the developer enters the directory containing the application and uses the Cloud Foundry command line interface, CFCLI, or Bluemix command line interface to issue a push command. The CLI tells the Cloud Controller to create a record for the application. The Cloud Controller stores the application metadata. Application metadata can include the app name, number of instances the user specified, the build pack, and other information about the application. Before uploading all the application files, the CLI issues a resource match request to the Cloud Controller to determine if any of the application files already exist in the resource cache. When the application files are uploaded, the CLI emits files that exist already in the resource cache by supplying the result of the resource match request. Ultimately, the uploaded application files are combined with the files from the resource cache to create the full application package. The Cloud Controller stores all the application package components into the blob store. Then the CFCLI issues the app start command. At this point, the Cloud Controller issues a staging request to Diego, which then schedules a cell to run the staging task. The task downloads Buildpacks, and if present, the app's Buildpack cache. It then uses the build pack that is detected automatically or specified with a -B flag to build the droplet. The task uses the instructions in the build pack to stage the application. While this is going on, the Diego cell streams the output of the staging process so the developer can monitor and troubleshoot any application staging problems. The task packages the resulting staged application into a tarball called a droplet, and the Diego cell stores it in the blob store. The task also uploads the build pack cache to the blob store for use the next time the application is staged. The Diego bulletin board system reports to the Cloud Controller that staging is complete. Staging must complete within 15 minutes or the staging is considered failed. Apps are given a minimum of 1 GB of memory to stage, even if the requested running memory is smaller. Diego then schedules the application as a long-running process on one or more Diego cells. Once the application starts, the Diego cells report the status of the application back to the Cloud Controller. One thing to remember is that every time you deploy or update an application on Bluemix, it will go through this staging process. And this concludes our video about build packs and runtimes and Cloud Foundry architecture. Thanks for watching.